Now we will look at the main type of workspace you will be using. There are two types of workspace in your documents, Part Studio and Assembly. Part Studio are used for creating custom parts. Because you will build from the kit of parts, there will not be much use here for you. What you will be mostly using is Assemblies. These are workspaces with tools intended to assemble the different parts together. The assembly gives you those tools to connect the parts as well as to make measurements. Before starting, it will be useful to change the workspace units. Navigate to the 3-bar menu and select Workspace Units. The most important one here is the distance. Click on inch and select millimeter, as many of your parts are based on the millimeter. The mass measurements are not as important to you, but while here, you can change the pound to kilogram. We must import the parts that will be used. We will use a piece of extrusion to see a few examples. To start, open the Insert menu by clicking Insert or pressing I. Navigate to the Center option. Now a search box appears here. You can search for Desafio Global 2023. Select the option that I do. There are many parts in this document, therefore it may take some time to load here, but it will be much faster after this has happened. Once the list has loaded, we can see and select the parts. To fully insert the part, click on them. Click on the part multiple times for more than one. Finally, select the green button to accept and insert. Now it is time to connect the parts. This is done with the mates. To begin, open the mate menu by pressing M. There are also toolbar buttons, but there are many, therefore this way is the easiest. You may notice the blue box. This is where the mate connectors will appear when they are selected. 2 mate connectors must be selected to complete the mate, and they must be on different parts, because Onshape will not allow us to connect a part to itself. Moving the mouse over a part, the mate connectors will appear. A mate connector can be selected by clicking on it. Sometimes it can be frustrating to select the mate connector as it will try to show ones on other faces. When this happens, hold Shift on the plane that you want and it will only show connectors on this face. Next, the other connector can be selected. Something to note is that the first part selected will always move to the second part unless it is constrained by other parts that will not allow it to do this. Only in this instance will the second part selected be the one to move. If a wrong connector is selected, it can be removed from the blue box with the small X. Now the parts are connected, but the exact position may not be correct. There are several adjustments that can be made. Flipping the primary axis is done with the straight arrow. This sends the part to the other side of the connector. Flipping the secondary axis will rotate the part 90 degrees at a time parallel to the connector circle. Notice the offset checkbox. This will expand a menu with 5 options. The first 3 will offset the part in a direction. These directions can be seen in the axis depicted on the connector: red, X, green, Y, blue, Z. The part can be moved in any of these directions. Usually the direction of the arrow is in the positive direction and the side without is negative, but sometimes it is the opposite. The only way to know is to see which direction it goes. You may have noticed that another menu has appeared here. It looks the same as the other one, but is smaller and does not have the offset settings. It is indeed the same and does exactly the same things, with one difference. When you click the green button here to accept, it will automatically open a new mate. That can be useful when you have many parts to connect. The mate is now ready to accept. The type of mate that we have just made is known as fastened, meaning that it holds 2 parts in the exact position and does not allow for movement. Again, there are many types of mates, but fastened is the one you will use most often. The other types of mates that we will likely be using are known as revolute and slider. The revolute type gives the same constraints as fastened, but allows for more rotation on the Z-axis. You can click the play button to see the animation of motion in the types of mates that allow it. The next type is the slider. This is similar to fastened, but the distance on the Z-axis is not constrained. It is possible to see how things will move by pulling on them. Left-click and pull a part to see how it moves or does not move. There's a problem here. All the parts are moving, and we cannot see them move independently. Right-click on a part, preferably the most central one, and select Fix, which is a black bar and some diagonal lines for an icon. This part is prevented from moving, and the others can be moved independently. To allow everything to move again, right-click the same part and select Unfix. The final tool in the assembly that will be useful to you is the measuring tool. This appears in the bottom right corner and looks like a spool of measuring tape. Click the measuring and a window tape will open. One thing to measure is the distance of one line on a part. Move the cursor to that part and the lines will highlight orange. Click the line that covers the distance you are measuring. This distance will appear in the measurement window. Here it shows only one measurement, but for more complicated measurements there will be additional information. If two parallel faces are selected, the parallel distance is the most useful measurement. You may have noticed the measurements for the different axes underneath it. These distances correspond to the axes shown on the cube in the upper right corner. The final type of measurement you'll be doing is between circles. By clicking on two circles, the distance shown is known as center distance. This is the distance between the centers of each circle. There are many more functions inside the assemblies, but these are the ones that are most relevant to what you'll be doing.